The life and discoveries of Johannes Kepler, the laws of planetary motion. Welcome back to our channel. Today, we're exploring the life and discoveries of Johannes Kepler, a pioneering astronomer whose groundbreaking work laid the foundation for modern astronomy and our understanding of planetary motion. Kepler's formulation of the laws governing the orbits of planets not only challenged prevailing beliefs, but also provided crucial insights that would influence future scientific thought. So, who was Johannes Kepler and what were his key contributions to astronomy? Let's dive into his life, his discoveries, and the lasting impact of his work. Johannes Kepler was born on December 27, 1571, in Weil der Stadt, a small town in southwestern Germany. He was born into a family with a complex history. His father, Heinrich Kepler, was a mercenary soldier, while his mother, Katharina Guldenmann, came from a more stable background. Despite facing hardships during his childhood, including the absence of his father and financial struggles, Kepler showed an early aptitude for mathematics and science. Kepler's education began at local schools before he enrolled at the University of Tübingen, where he studied theology but quickly gravitated toward mathematics and astronomy. It was here that he encountered the revolutionary ideas of Nicolaus Copernicus, who proposed that the Earth revolves around the Sun, a concept that would profoundly influence Kepler's thinking. After completing his studies, Kepler became an assistant to the renowned Danish astronomer Tycho Brahe in Prague. Brahe had amassed extensive observational data on planetary positions, which would prove invaluable to Kepler's later work. Under Brahe's mentorship, Kepler honed his skills in observational astronomy and began to formulate his own theories about planetary motion. Upon Brahe's death in 1601, Kepler inherited his extensive collection of astronomical data. This wealth of information would allow him to develop his groundbreaking laws of planetary motion. Kepler is best known for formulating three fundamental laws that describe how planets move around the Sun. Kepler's first law, law of orbits. This law states that the orbit of a planet is an ellipse with the Sun at one focus. This was a significant departure from the long-held belief that planets moved in perfect circles. By analyzing Brahe's data on Mars, Kepler determined that its orbit was elliptical, leading him to extend this finding to all planets. Kepler's second law, law of areas. This law states that a line segment joining a planet and the Sun sweeps out equal areas during equal intervals of time. In simpler terms, this means that planets move faster when they are closer to the Sun and slower when they are farther away. This discovery explained why planets appear to move at varying speeds in their orbits. Kepler's third law, law of periods. This law establishes a relationship between the time it takes for a planet to complete one orbit around the Sun, its orbital period, and its average distance from the Sun. Specifically, it states that the square of a planet's orbital period is directly proportional to the cube of its average distance from the Sun. This mathematical relationship provided a way to compare different planets' distances and orbital periods. Kepler's laws revolutionized our understanding of planetary motion and provided strong support for the heliocentric model proposed by Copernicus. By demonstrating that celestial bodies follow predictable mathematical patterns, Kepler laid essential groundwork for future astronomers like Isaac Newton, who would later develop his laws of motion and universal gravitation based on these principles. Kepler's work also marked a shift toward empirical observation in astronomy, a practice that emphasized data collection and analysis over philosophical speculation. Despite his scientific achievements, Kepler faced numerous challenges throughout his life. He lived during a time marked by religious conflict and political instability in Europe. As a Protestant in predominantly Catholic regions, he often encountered discrimination and hostility. In addition to these external challenges, Kepler faced personal hardships as well. He lost several family members to illness and struggled financially throughout much of his life. Despite these difficulties, he remained committed to his scientific pursuits. In 1619, Kepler published one of his most important works, Harmonices Mundi, The Harmony of the World. In this book, he explored not only planetary motion, but also the underlying mathematical relationships governing celestial bodies. He sought to demonstrate how harmony exists in nature through mathematics, an idea deeply rooted in ancient philosophy. In Harmonices Mundi, Kepler introduced concepts related to musical harmony and proportions in relation to planetary orbits. He believed that understanding these harmonies could reveal deeper truths about the universe, a reflection of both scientific inquiry and philosophical exploration. Johannes Kepler passed away on November 15, 1630, but his legacy endures through his significant contributions to astronomy and mathematics. His laws of planetary motion remain foundational principles in celestial mechanics today. Kepler's work influenced not only future astronomers, but also philosophers and scientists across various disciplines. His emphasis on empirical observation paved the way for modern scientific methods, encouraging subsequent generations to seek knowledge through observation and experimentation. Today, Kepler's laws continue to have practical applications in fields such as space exploration and satellite technology. Engineers rely on these principles when designing spacecraft trajectories or calculating satellite orbits around Earth. Furthermore, Kepler's ideas have inspired ongoing research into gravitational interactions among celestial bodies, contributing to our understanding of complex systems within our solar system and beyond. In conclusion, Johannes Kepler's contributions to astronomy have fundamentally shaped our understanding of planetary motion and laid essential groundwork for modern science. His innovative ideas challenged established beliefs while emphasizing the importance of observation and mathematical reasoning. Thank you for joining us today. If you enjoyed this video or have any thoughts, please comment below. Don't forget to leave a like and subscribe for more.